This topic we will talk about other descriptions of discrete functions. There are two other ways of describing discrete functions with which you should be familiar. The first, sets of ordered pairs. The second, mapping. We will start with the table description with which we have been using and translate it into each of the two new types of description. By the end of this unit, you should be able to flexibly recognize a function provided to you in any of these forms. Sets of ordered pairs, example number 1. We have been using a table like this to describe a function. However, you will sometimes be provided a function which is described as a set of ordered pairs, as you see here. This set of ordered pairs convey the exact same information as in the table. The x and y values in each row represent an ordered pair. The set of all the rows translated into ordered pairs describe the function just as the table does. Provide some further clarification. So right here, -3 and 4 describe an ordered pair, which you see here in ordered pair form. Here we see -1 and 5. Here they're grouped together in ordered pair form. In this table of values, we see 0 and 8. We formed ordered pairs and put them in their set notation. And with 4, 9, we did the same thing. And then, of course, go back here to 3, 11. And you see here we grouped 3, 11 together. So we have taken the values from this table and formed ordered pairs. And then we grouped them together using set notation. So they're all grouped together using the curly brackets for set notation. I want to reiterate, this set of rows translated in ordered pairs describe the function just as the table does. Two different ways to represent the same thing. Sets of ordered pairs, practice number 1. Translate this table description of a function into a description using a set of ordered pairs. Here's an opportunity for you to pause the video, create your set of ordered pairs using this table. When you have your answers, resume watching the video. And welcome back. Let's see the answers. So we created a set of ordered pairs that looked like this, and we did that by grouping values in this XY table. So we have 7, 5 formed this ordered pair right here. 3, 2 formed this ordered pair here. 1, 4 formed this ordered pair here. And 2, 8 formed this ordered pair. And I'm running out of colors. I'll just use yellow again or green again. 6, 11 formed this ordered pair here. So we've taken the table of values, translated them into ordered pairs, and grouped them together using set notation. Answers may vary based on the chosen order of ordered pairs. You can change the order. I chose to go from top to bottom, but answers can vary. Sets of ordered pairs, practice number 2. Here's an opportunity to create a table that describes this function. So we have a set of ordered pairs. We're going to reverse the process. Can you make a table? Pause the video, create your table, and when you're finished, resume watching the video. Welcome back. Let's take a look at the table. The table of value will look like you see here. I chose to take X values in order from largest to smallest and group them with their associated Y values. I'll just do a couple for you. So these are all the X values. All right, so you notice I put them in -5, -2, 1, 5, and 7. And then I grouped them together with their associated Y values. Okay, so we have 3, 4, 5, 8, and 9. Just make a column based on the ordered pairs you see here. Again, answers may vary based on the chosen order of rows. Okay, I chose to do this from smallest to largest based on the X. There could be other options. Answers may vary. Here's an example of a mapping. Mappings are another way to describe discrete functions. The below map describes the same function as the table. The order in which the numbers are written does not matter, just that each arrow goes from an X value to its corresponding Y value. So this is the x here. Okay, so we have x, and this is y. We can write the numbers in any order we wish. We don't have to follow a specific order. Typically, we do go from smallest to largest, but not necessary. What does matter is that the x value is mapped with an arrow going to its corresponding y value. I'll do a couple for you. So you'll notice here we have 311, right? So 3, there's an arrow going to its corresponding y value, 11. Here we have negative 3, 4. So here is the x value, negative 3. There's an arrow going to its corresponding y value, 4. I'll do one more. Let's take negative 1 and 5. Here's negative 1 and x. There's an arrow going to its corresponding y value, which is 5. So once again, just to reiterate, the order in which the numbers are written does not matter, just that each arrow goes from an x value to its corresponding y value. Here's the first practice with mappings. Draw a map based on this table. So what you'll do is make two rectangles, one for your x numbers and one for your y numbers. And then you're going to draw arrows from the x value to its corresponding y value. Pause the video, try it, and when you've completed your mapping, resume watching the video. And welcome back. Let's take a look at the mapping. So here's my rectangles. I do want to point out that I did label them x and y. Okay, so we labeled x and y here. The x, I went in order from smallest to largest. Okay, so notice these are all the numbers. Okay, we got negative 2, 0, 1, and 2. Negative 2, 0, 1, and 2. They're just in order from smallest to largest. And I have the corresponding y values. Just have 5, 7, 8, 9, or 5, 7, 8, 2. Here we go, 5, 7, 8, and 2. They're just in different orders, but what counts is drawing the arrows. That's what we need to pay attention to. So here we have negative 2 and 5. And negative 2, there's an arrow going to positive 5. If I said negative 5, I meant positive 5, sorry. Let me try another. Let's take 0 and 8. Okay, so here we have 0. There's an arrow going to its corresponding y value, 8. Let's take 1 and 2. Here is the x value, 1. There's an arrow going to its corresponding y value, 2. And then finally, we have 2 and 7. So here's the x value, 2. There's an arrow going to its corresponding y value, 7. And this is what a mapping looks like. Mapping, practice number 2. This time you're going to create a table based on this map. So create an XY table, take a look at the map, and then pause the video and fill in the appropriate values. Make sure you're matching the X with the appropriate Y. And welcome back. Let's take a look at the table. So you'll notice that 4 maps with 6. So 4 maps with 6, so that's what we did here. We mapped 4 with 6. 5 maps with 3. So we put 5 here, we mapped it with 3. Negative 3 matches with 1. So we put negative 3 matching with 1. And then finally, negative 5 matches with 2. So we placed negative 5 with 2. Now the answers may vary based on the chosen order of x and y values. So some people may put it in this order. Another person may put it in a different order. But as long as the appropriate x value is matching with its corresponding y value, it could be correct.